this unit, we are looking at relationships, but specifically trying to look at what makes a relationship a function. We're really just looking at sort of an introductory thing to functions. You'll get into them more in Algebra 2 in a couple of years. And if you go on with math, they'll become even more important. So this is sort of a brief introduction. Now, anything that you can assign an ordered pair to is a relation. So as long as I can assign an ordered pair to something that's going on, it's a relation. But not every relation is a function. So a function is a relationship between two variables where there's a unique, which means one and only one, output for each input. Now, that doesn't mean that there can't be several inputs with the same output, and we'll get into that in a little bit. The domain of a function is the set of all values that are inputs. Now, on a typical graph, x comes before y, right? Domain comes before range. So if I'm looking at a graph, the domain is all of the possible x values for that relation or function. The range is all of the possible y values. And they're talking about inputs and outputs. Well, x is your input and y is your output. So domain comes before range alphabetically, x comes before y, input comes before output. And those things are the things that go together. So when I look at this table, they want to know whether it's a function. The first thing I'm going to do is my inputs, remember, are my x's, my outputs are my y's. It is a function, it's not a function if the same x has two different y values, which means table A, I can just at a glance tell that this is going to be a function because there isn't the same x twice to go to two different y values. So my answer A, and you're going to be required on your homework if it asks you if it's a function or not, to not just say it's a function or not when they're giving you the tables like this, but you also have to explain. So there is, so function would be my first thing that I say, and then y, there is a unique output. If you want to write out the whole word, there's one and only one output. You can do that. There's a unique output for each input. Then it says give the domain and the range of the relation. There's domain and range even if it's just a relation and not a function. So my domain is the set of numbers 1, 2, 3. My range is the set of numbers 2, 4, and 6. And I'm going to ask that if those are not in order to begin with, you put them in order from least to greatest. B, I have to put C somewhere else. B is not a function because my x, my y, my input, the input of 1 here has an output of 1 here and an output of 5 here. So the same input has two different outputs. So B is not a function because the input of 1 has two different outputs. It is really hard to write neatly with this thing, and for some reason it's getting harder all the time. Even though it's not a function, it still does have a domain. And again, that's the set of all numbers for the input, and I asked you to put them in order, so it's the set 0, 1. Even though 1 repeats, I don't repeat it in my set. And my range is the set 1, 2, 5. I'm going to have to go up here for C. Your paper's set up a little differently. So C. Again, if the input is never repeated, it can't have more than one output. The output of 0 has all kinds of different inputs. That's okay. This is a one-way street. The input can't have more than one output. So it's a function. And function can be sometimes abbreviated to FCN. You'll see that. I probably should undo that, get you guys used to writing the word function. So it's a function. And why is it a function? Each input has a unique output. And you will be required to write this on your assignment. So get used to it, and on your test. Why is it a function? Why is it not? The domain, the set of numbers 1, 2, 3, 4, 5, 6, they're already in order, so I don't have to reorder them. The range is just the set 0. Now when you're making these brackets, some people have a hard time. It's like an S and then a backwards S. And on this side it's a backwards S and then an S. Now, when it's a graph like this, there's something called a vertical line test. Because if the input is x, if the same x value has two different outputs, what you're going to find is that at some point I could draw a vertical line, like this is not a function because this x value has two different y values. This input has two different outputs. At some point I could draw a vertical line and hit 2 points in this relation at the same time. So when it's a graph, not from a table, when it's a graph, you can say it's a function or not a function because it does or does not pass the vertical line test. So this first one is a function, and y passes vertical line test. Because there is nowhere on that graph that I could draw a vertical line that's going to hit that red function or that red relation in more than one place. This one's not a function though, because I could draw a vertical line here and it hits this relation in two different places. So not a function. You may have to write these a little bit smaller above your graph or around your graph, or maybe number them and then write them with things on the back. Not a function does not pass the vertical line test. Now, even though this gets to be kind of steep, it's never purely vertical. There's no place that I can draw a line that's going to hit this relation in more than one spot. So function, again, I do need to write out the explanation for each one of these, passes the vertical line test. Is not a function. I can hit this one in 3 different places at once. So not a function. And you always have to give your explanations on these for me. Does not pass the vertical line test. And you can only use the vertical line test on graphs, not on tables. Now it looks like there's one point directly above another point here, but since this is an open circle, it means that that point is not actually included in this graph. This little line segment goes all the way up to that point, but then doesn't include it. So even though I can draw a vertical line that looks like it goes through 2 points, this is actually the only point that's part of that relation that's on that vertical line. Now, if any of these little endpoints that are open were actually shaded in, then it wouldn't be a function because there would be 2 points where one's directly above another. So this is a function. And then again, why is it a function? It passes the vertical line test. Now, that is a basic look at functions.